In this video, we're going to look at what we do if we need to factor a trinomial with a leading coefficient other than 1. So in the last video, we looked at what about this situation, where the leading coefficient, the number before the x squared, is a 1. But this time, it's a 2. So that changes some things about our strategy. Because before, we really only had to look at this constant. We needed some way to rewrite this so we could factor it nicely with this. But now we need to rewrite it so that it'll factor nicely with both this and this. And so the way we do that is we take this number that's the constant term and this number that's the coefficient of the leading term, and we multiply them together. So since 2 times 15 is 30, now we need numbers that multiply to 30 rather than just to 15, so that we get something that will factor with this one as well. And since we're still rewriting the middle term, we still need it to add to 13. And we can just use a guess and check process. If you've started to develop an intuition about where's a good place to start guessing, you're allowed to use that. Or you can just start with the first one you can think of and go on through. That's still fine. So let's see, 30, that could be 15 times 2, but 15 plus 2 is 17, so that's a no. Well, 30 could also be 10 and 3, so 10 times 3 would be 30. 10 plus 3 would be 13. So that's how I want to break this up. So, just like before, I rewrite it as 2x squared. And I rewrite my 13x as 10x plus 3x plus 15. And now I can factor by grouping. And I am going to start using a little less detail than I did in some of the previous videos, just because that's something that you do as you get more comfortable. And by this point, you should be able to hopefully see some of those steps that I'm leaving out. And how many steps to show is a combination of what you need to understand it and what your audience needs to understand it. And so I'm assuming my audience is ready to see fewer steps. But out of both of these, I can factor out a 2, because that's a 2 and that's a 10, and an x, because that's an x squared and that's an x. So I can factor out a 2x, leaving me x plus 5. Over here, I can factor out just a 3, leaving me x plus 5. Well, I can still factor an x plus 5 out of each of those. But now instead of this one having just a plain old x, my other set of parentheses has a 2x. Because one of these had to have a coefficient in order for me to get, after I've multiplied them, a number in front of that x squared. So one of these needed to have a coefficient other than 1 at this point as well. So I'll do another example that's just slightly more complicated because it has a minus sign in it. So we have to start thinking about signs. So 3x squared plus 2x minus 8. And I need numbers that when I multiply them, I get negative 24, because 3 times 8 is 24. And this is negative, so it'll be a negative 24. So since 3 times negative 8 is equal to negative 24, I need numbers that'll multiply to negative 24. Since this is a 2, I need numbers that add to 2. 24 is one of those numbers that I can write a bunch of different ways, so kind of world's your oyster on where to get started with the factors of 24. I know I want factors that are fairly close together because I get 2, and I know I want the bigger one to be positive because it's a positive 2. So I'm going to start with 3 and 8 just because I know those make 24. I just multiplied them. 8 minus 3, 5, 8, and I take away 3 is 5. So that was not correct. I need ones that are even closer together than 8 and 3. So 6, negative 4. 6 minus 4 is 2. So 6 and negative 4 is the way I want to break up that 2. And if I couldn't see this right away and I started with, 24 times negative 1 and just had to make the whole list, that's fine. You'll gradually build an intuition as you do more and more of these. So I have 3x squared plus 6x minus 4x, and that's the same as 2x, so minus 8. And I need to factor by grouping, so that would be 3x, x plus 2. That would be minus 4, x plus 2. And I wanted these to be the same, so that's how I knew I wanted to have a negative 4 here, rather than factor out a 4 and have negative x negative 2, is because I knew this had to match that. Otherwise, my next step doesn't work. And then I can just pull in my 3x and my minus 4. And this is factored. I'm going to do one more example with bigger numbers. So, what if I had 10x squared plus 29x plus 21. So the same strategy applies, it just, there's more possibilities here. 10 times 21 is 210. So I want numbers that multiply to 210. And I need numbers that add to 29. So, I just sort of start guessing and checking and seeing where I'm at. 10, 21 would definitely work. That's how I got there. But 10 plus 21 would be 31. So that's close, but not going to work. And maybe this is one that the numbers are big enough that I don't really know offhand all of the factors of this. And there are several different strategies you could use. But I think the strategy most students will use is to do some guessing and checking with a calculator. So I'll show you how you can do that. If I want to know if something is a factor of 210, I can just divide by it. So I already know that 9 is not a factor of this because I know a factoring trick for 9s. But if I didn't know that, I could try dividing by 9, and I'd see, oh, I don't get a whole number. 9 doesn't work. What about 8? Nope. Not feeling good about my chances with 7. Oh, it works, though. Weird. Okay. So I could do 30 and 7, but 30 plus 7 gives me 37. So I can kind of tell I'm going the wrong way here. Like, things were going better when I had 10 than when I had 7. So I want to start guessing bigger numbers than 10 instead of smaller ones, maybe. So 11, that doesn't go well. 12, that doesn't go well. Don't have a lot of hope for 13. Yeah, that didn't go well. 14, hey, it worked. Okay, so 14 and 15. So I'm just finding factors. And because I never had to memorize my 14 times tables, I didn't immediately know, oh, 14 times 15, that's 210. And so I used a calculator and did some guessing and checking. And there are other strategies you can use if you don't have a calculator. And if you want to see those strategies, come to office hours and I will show them to you. (14 plus 15 is 29. So I have found the set of factors that will work for this problem. (10x squared plus 14x). Well, let's see. I can definitely factor an x out of both of those and a 2. And that's really all I can get because 10 is 2 times 5 and 14 is 2 times 7. So all I can get out of that is 2x, leaving me 5x plus 7. And here, 15 is 3 times 5, and 21 is 3 times 7. So all I can factor out of that is a 3. So now I get 5x plus 7 times 2x plus 3. So this is a situation where even after I'm done factoring, I have leading coefficients in front of each of the x's in my factors. And that's why this one got so big so fast. So those are just some examples of factoring trinomials with a leading coefficient other than 1.